In this video, we're going to learn the very last rule for taking derivatives. And after this, you should be able to take the derivative of any function that you are given. So the rule here is the derivative for the natural logarithmic function. And it says that if you're given f of x equals ln x, that the derivative of this, f prime of x, is just 1 over x. And it's only 1 over x if there's a single x value here. If you had something like this, f of x equals ln of x squared, notice there's a quantity there. That's actually the composition of two functions. And if that's the case, then you have to apply the chain rule. Okay? And it's similar to what we did with the exponential function, natural exponential function, and similar to what we learned when we took the derivative of our trig functions. If there's not a single x value there and it's the composition of functions, you have to use the chain rule. So the chain rule says if you have a function and you want to take the derivative, it would be 1 over, so f prime of x would be 1 over that function, so x squared, times the derivative of that function, so times the derivative of x squared, which is 2x. Again, it's ln of this function, so it's going to be 1 over that function x squared times the derivative of x squared, which is 2x. And I can simplify that to 2x over x squared, which is just simplified to 2 over x. Let's look at another example and see if you can't do it alone. So we have ln sine of x. This is a pretty complicated function here. Pause the video and see if you can't take the derivative. All right, so the derivative formula says we have ln of a function g of x, so we're going to write 1 over that, 1 over sine of x. And then we're going to multiply times the derivative of that function, and the derivative of sine of x is just cosine of x. So I can simplify that to cosine of x over sine of x, and some of you may recognize that as cotangent of x. Hopefully you got the same answer.